Okay, we need to do a quick review of chapter 5, and as we have been writing plenty of functions just now, I feel that your memory is fresh, and I just need to uh, emphasize certain things like local variables versus global variables, and arguments um, versus parameters. Okay, let's concentrate on this slide. First of all, I am to remind you that main consists the main logic of the program, and there can it's a function in its own right. And by the way, this is a void function. This function does not return anything, meaning it doesn't have a return statement. It depends on another function, show sum, and that is how main functions are usually, or always. And what do we need to know about this? First of all, show sum needs to be needs to be defined, meaning this code needs to be written before we call it over here. And actually, it would be better to switch them over. Def main should be below show sum. In any case, show sum takes two arguments. The arguments are 12 and 45. However, num1 and num2 are called parameters. Parameters are formal variables of the function. They are not referring to any values. As opposite to when we call a function, we supply values to the parameters, which could be in the form of variables or actual constants like they are over here. Show sum is also a void function. It just prints. It does not return anything. Notice that parameters are actually passed into the function. In the values actually passed into the parameters in the order they appear. So you can pass just by choosing the order the same as you need, or you can alternatively do it using the following syntaxes: parameter equal value inside the function, and that way you don't need to worry about the order of them. It may be a good idea to remember various parts of the function. So this is definition header, def function name, in parentheses there can be parameters, and then colon, and then indented block of statements. So def stands for define or definition, and function name should be telling you something, and the conventions are basically for the function naming the same as conventions for variables. There are two types of functions: void functions and value returning functions. Void functions are the ones that don't have a return statement. They can print, they can do something else, but they don't have a return statement. And value returning statements, the ones that are returning a value which you later save as a variable. For example, when you do an input, you save the result as a variable. Same with int and float, in order to use it later. Those are standard Python functions, and we will see the custom functions shortly. I definitely need to talk about the local variables. Those are variables that are assigned a value inside the function. It belongs to the function. Outside program does not know about this variable, and when you return it, you return the actual values of these variables, and if you want the outside program to reference them, you are assigning them variables in the outside program or outside function. So the scope of a local variable is a part of the program where they can be accessed. For local variable, it is a function in which it is created. Thus, different functions can have variables with the same name, they don't know about each other, that is okay. Now, argument is a piece of data that is sent into a function. For example, x equals to 5, I can send it into a function, like it is on this in this slide. So def main, that's my main logic, value equals 5, shall double, we call shall double with the argument value. Value is a variable that actually points to a number or is equal to a number 5. Now let's look at the def shall double number that should be defined by the time we call it. Shall double number, and result is number times 2, and then print result. So number in this case is a parameter that is an abstract variable by itself when we define this function. It doesn't refer to any value. It is an abstract variable to work with, and it's called a parameter. In this example, we can define a value 99 in the main and send it to change_me function. So it takes the value as an argument. The argument is actually 99. And the change_me function attempts to change it to 0. And locally, within the function, it does it. And when we run this function, it will actually show the new value over here. However, as soon as it jumps back to the main, it actually forgets the value and it remembers the previous value as it was. So change_me cannot change the value in the outside program, the variable value in the outside program. Global variable is created by a Simon statement written outside of all functions. It can be accessed anywhere, and it should be avoided. Changing it inside the function should be avoided. So if you created something global, it's cool to have it as a constant, global constant. That is not something you change throughout your program. However, you should avoid doing this kind of global variable variable declaration. Here is a little example we're going to modify. X equals 10. We want to define a function, def function a, return a plus 2. Function of x works perfectly. Maybe I should do a print statement to make sure we can see the result. Print function of x. So we are taking x and passing it as an argument to the function. A is a parameter of this function. Okay, we got 12 as expected. Everything works well. Now, we did not really change x inside this function. We just returned x plus 2, basically. What if we try to change x? Actually, before we do that, how about we do this? So this is a global constant. We can return a value bigger than 2 from this. Increase the value by 2. Yep, it works. This is a global constant. We did not change it, and everything worked perfectly. Now, if you try to do this and then return x, so increase x by 1 and then return x, that will cause an error. Feel free to stop the video and carefully read the error, especially the last two lines. This error means that the Python assumes that the x inside the function is a local variable different from the global variable x. And you are trying to change its value before you actually describe what the local variable is. So in this case, we wanted to identify x with the x as a global variable. So I do global x And now my program worked, added 1, but you should not do this. If you choose to do that in a final project, that's okay with me. I'm not going to punish you in this particular case, but in general, changing global variables inside your functions is a very toxic thing to do. And imagine having a huge program somewhere, there is an obscure function that actually changes the global variable. That is very hard to work with or update. So avoid global variables. Global constants are okay. As long as you are not changing them, they are okay. And lastly, I need to remind you about imports. So we have been importing turtle. We have been importing random. We were importing math. And we were importing something else. Remind me what it is. In any case, there are some functions that are built in Python itself, and there are some library functions that are uh, that you can import. So there are some standard modules that allow you to for standard modules. For example, turtle was a standard module, and so is random. And in general, to import those functions from those modules, you do import the entire module, and there are other ways to do it. Just import a particular function if you need it, but we're not talking about that. So standard library functions and basically functions that written by someone else are usually a black box. They take input, they produce output. You need to know what kind of input is admissible and what kind of output they produce. And as you gain more experience, you will be curious how they actually look inside, and you can always look inside them and see how they were written. We talked about random module. Definitely be familiar with the random module. And by the way, general format for calling a function from a module, module name dot function name parentheses. When we worked with math module, we called for pi, and we did math.pi without parentheses because pi is a constant. So we did not need parentheses there. We need rendint, that is the range including lowest and highest, and we did talk about that. So this is a rendint. Maybe I'll switch to slideshow. A random rendint from 1 to 100, including the ends, choosing a random number from 1 to 100, including 1 and 100. Okay, and we have randrange, which works like a range, so not including the upper limit. Random returns numbers between 0 and 1, and uniform returns numbers random float between numbers that users specify. By the way, a very easy way to remind yourself how these functions work or what arguments they have, you can do import random like any other package, and then call random dot rand range open parentheses, and it shows you start, stop, and step. So parameters of this function. And that should work for any standard module. There is a notion of random number seed that is for reproducing. If you are working on a program or function that is using random module and you have been running into error, maybe sometimes, you might want to fix the seed. So in this case, the random numbers that are generated will always be the same. And if you fix the seed, that will maybe make it easier to debug or like send a report on the error to somebody. Yeah, as we've seen in countless examples, return expression returns, this is a return statement for a function. Don't overdo expressions. It can be a plus b, where a and b were variables inside the function, but it shouldn't be something crazy long, crazy one-liner. We talked about this kind of functions, but maybe I'll quickly show you an example. Sum of two numbers, instead of printing, it returns result. So num1, num2 are two parameters. Compute sum, return them that. And in the big program, you would have to save this returned result as a variable. So the way you call this function, for example, I will use in the big program for result, I will use variable res equal to sum, and here two numbers, 10 and 12. So res will be equal to 22. Well, not much about IPO charts. You can look at what they are, and basically they describe input and output of the function and also explain what the function does. You can return strings just as well, of course. This function just gets the name of somebody, and name equals to input. Input is a standard function in Python, as you know, and prompt gets some, user gets some, has some input, it's saved in the name, and then you return the name variable. I recently had an example where the function returned a boolean that is true or false. That is also possible and doable and very useful. And finally, we talked tiny bit about math module. If you are math savvy, you know what all these things are. They are very useful, although I never used a raw math module myself. I usually use things that are built on top of it. And finally, remember that you can store functions in separate modules, and that is modularization of your better modularization of your project. So one file is a module, it contains all the functions. Another file contains a main function, mainline logic of your program. And I think that's about it. We are done with the review.